right, so today we're going to write a piecewise equation from a piecewise graph. So to do that, we've got to recognize that there are two pieces to this function. This is a constant piece, and this is a linear piece. The difference is they're both lines, but this is a horizontal line. Horizontal lines are always a y equals a number equation. If it has any sort of diagonal slope to it, it's going to be a y equals mx plus b equation of a line. Now, y equals mx plus b is going to be, that is slope-intercept form, is actually not the equation I'm going to use today. I'm going to use y minus y1 equals m times x minus x1. That is called the point slope form of a line. The point slope form is useful when you just have a point and a slope. This slope-intercept form is valuable when you have the y-intercept readily available. That's the y-intercept, and this would be slope. So we can use this form, and I'll show you how to do that one in a moment, but I'm actually going to start and prefer to use point slope form for these piecewise functions because most of them aren't touching, as you notice here. This is not touching the y-axis. It would if it continued, and I could see where it goes, but I'm going to act like it doesn't because subsequent problems will get more difficult. And so I want to be prepared with this point slope form tool in my math toolbox. So first, I'm going to talk about this. I'm going to go from left to right, talk about this interval, this snippet of a horizontal line. It goes through the y value of 6, so the equation is y equals the number 6. So what we do is go down here to my piecewise definition, and I type a 6 here because the output, the height will be 6. And then when we say over here is the rule for what? Well, for any x values that go from this leftmost piece, which is -4, to the rightmost piece, which is 1. And you see that it does include 1 with a solid dot, does not include 4. We want to talk about all the x values in between there. So everything parentheses, solid, shading, and then a bracket, if you would, from -4 to 1. The way that we write that with an inequality down in here is going to be, start with -4, the leftmost bound is less than x, and that's less than or equal to 1. And so that defines this function in function notation to be output of 6 for any input from -4 to 1. So now we need to turn our attention to that linear component. And this, as I mentioned before, I'm going to use the point slope version of a line to identify what the equation of this line will be. To do point slope form, I just need any point on it and the slope. Well, the slope, if we just count rise over run, we see we need 2 dots to count the rise and the run between them. We'll see that it goes down 1, 2, right 1. Now first, I do want to say again, it went down, which means there is negative slope. You can see from left to right, we're going to have negative slope. So make sure no matter what you do, you get a negative answer. And then went down 2, that's a -2 move, and then a right 1, which is a positive move. So my slope is -2 over 1, which is best written as just -2. So that's my slope, and that's going to go right here in the function, -2. Then I need any point, like this one. This point right here is 5, -5. So that coordinate, 5, -5, is my 1 coordinate. In fact, I'm going to call it my x1, y1, because it's my 1 coordinate. So I put the y1 where the y1 is, that's -5. I'm going to put it in parentheses, equals, and then I'll put y minus, so all this stuff's just coming down, equals -2 parentheses, the x comes down, minus the x1 is a +5. Now, all I have to do in order for me to write it in this function notation right here, this is f of x equals, f of x is y, so I need to say y equals, anything in here is what y is. So The only thing I have to do with what I've written in my point slope form is take this piece, this minus minus 5, and move it to the right. So first, let's take care of that minus minus. It's actually plus plus. So it's y plus 5 equals negative 2 times x minus 5. And I'm going to move that plus 5 to the right by subtracting 5 from both sides. When I do that, y is now isolated. Y equals negative 2 parentheses x minus 5. And then minus 5 goes on the back side because this is all written as a product. Minus 5 just hangs out in the back. And I have now isolated the y. This is all. I don't have to keep simplifying. I don't have to distribute the negative 2 and combine like terms or any of that. This is what y equals, which means this line is defined by this expression. So I can type exactly that down in the box and say negative 2 parentheses x minus 5 close parentheses minus 5. That's the equation of this line. And then I just have to define when to use that line. Well, that line is supposed to be getting used from, it begins at 1, and then you stop using it here at 6. So I write in there, left bounded at 1, and it's less than, not equal to, because it has an open dot at 1, x, and then less than, not equal to again, 6. So it's using that rule from 1 to 6, not including the end values. So that is my function notation way of writing this constant function and linear function in the same piecewise expression. So now I'm going to back up one step and show how quickly you could have used point slope form to have found the equation of this line. And I'll point out that it's the same as the point slope form. We can use the slope intercept form. And so the way that we do that would have been to highlight the fact that our slope was down 2 over 1. So I could go up 2, left 1, and found my y-intercept to have been 5. So this equation of this line, I could have just said y equals, the slope was negative 2, x plus 5. So rather than do the point slope form, which I did, I could have done this also, and I could have taken this 2x plus 5 and put it instead in here. Both are sufficient, both work, but later context will require point slope form because I won't be able to get a good read as to where it would have touched the y-axis as easy as just going, oh, it's just up 2 over 1, there it is at 5. So that one worked here, but later problems will be a little bit more complicated to find that. So let's try another example. So in this case, we've got 2 linear functions, no constant this time. And I'm going to, on both of them, use point slope form once again. All point slope requires is a point, like this one right here, which is the coordinate negative 5, 6, and a slope. And looking at this slope, the first thing I want to do is say, with my eyes, it's going down from left to right. So I'm going to get a negative slope value. So no matter what I do, rise over 1, make sure it's negative. And then I'm going to see it goes down 1 over 1, down 1 over 1. So that is a slope of negative 1. So using point slope form, y minus y1 equals m times x minus x1. I replace the 3 little pieces. I've got m, and then I've got x1, y1. And so I write y minus the y1 is 6 equals negative 1 times x minus parentheses negative 5. And all I have to do with that is move this 6 to the right-hand side. I'm probably going to go ahead and change this minus 5 to a plus also. So if I just add the 6 to the right side of the expression, I will have isolated y equals negative 1 times x plus 5, and then plus 6 on the outside. That's the exact definition I use for that segment of this piecewise function. So I go ahead and type it down below. Negative 1, parentheses, x plus 5, and plus 6 on the outside. And then I just have to define the rule for when I use that. So now I look back at the graph, and I notice that it is for everything pointing off to the left from this x value of negative 5. So this -5 is the key to when this thing starts. It is a solid dot there. So what I need to write in here is this is to be used for everything left of. So I use x less than or equal to -5. That will define it to continue and have that arrow pointing off to the left and including that value at -5. So now you turn your attention to the right-hand linear function. And just like before, I'm going to use any point and the slope. I'm going to use this point right here. This is the point 8, 0. That's my x1, y1. And then I need to figure out what the slope is for this line. Second expression where I have a negative slope. It's going down from left to right, so make sure you get a negative slope value. And I'm going to go from this dot down 1, right 2, down 1, right 2. So that's -1/2 is my slope. So I'm going to jump back into point slope form. Y minus y1 equals m times x minus x1. Y stays, minus sign stays, replace y1 with 0 equals m is -1/2. Parentheses stays, x stays, the minus sign stays, x1 is 8, close parentheses. Now this one's cool because I chose an x-intercept that this part goes away. -0 is just 0, it's gone. Y equals exactly -1/2 x minus 8 in parentheses. So that is the equation of this line in point slope form, but it has the y by itself, so I go ahead and write that expression down here as the rule for everything that's going to be right of 4. So I'm going to write -1/2 times x minus 8. And then because this rule is, you notice here, it starts at 4 and then starts moving to the right with an open dot here, I'm going to say down in the box, x greater than, not equal to, 4. That should work as my equation for this piecewise graph. All right, so on this final example here of this type, we have another constant piece, but the key on this problem was that this particular right-hand linear function starts heading down, and you definitely would want to be leaning towards using point slope form because this one really shoots down below where you can even see that it might hit the y-axis. So you could do it if you really expanded upon this graph properly, but it's a lot more convenient to stick with point slope form, as I've been trying to convince us in this video. What you'll see here is that the y height is on this left-hand constant function -5. So you would say y equals -5. That's my definition for that one. In the box, you just write the 5 because f of x is already taking care of the y equals part for us. So we just say -5 right here. And we define that rule to be used for everything left of -3. So we say x is left and equal to, so we got to use less than or equal to symbol, -3. So that includes the -3 and points off to the left. And now we've got to figure out what the equation of this right-hand line is. So I'm going to erase my little arrow. And let's focus on point slope form. To use point slope form, y minus y1 equals m times x minus x1. To use that form, I need to identify a point and a slope. Any point will do. Little bit less convenient this time. I can't have the y-intercept or the x-intercept like I did last time. So here I have this coordinate. I'll just choose x 8, 1. So x1, y1. And then the slope. Find any 2 points. You can count the rise and the run. So you see it's the rise of 2, run of 1. And again, it is a positive slope here. We're moving up and to the right. So we should get a positive 2 over 1, which is just a 2 is my slope. So I'm going to put that in now, plug that in. So I'm going to write the y minus stays. The y1 gets replaced with the value of 1 equals the m I just found is 2 times x minus x1. The x1 is 8. Now all I have to do before I write it down in my box below is I need to take this -1 right here and add it to the other side to get y by itself. So add 1 to both sides. And then just make sure that this 1 doesn't get in here in the parentheses at all, because this is all connected. That's a single term with the product going on there. So it's just y equals 2 x minus 8, and then plus 1 on the outside. So that is my linear rule for everything that is working right of 4. So I say 2 parentheses x minus 8 close parentheses plus 1 is the rule. And then I need to use that rule for, you see here, the x value at 4 starts the process of using that line. So I say x greater than 4. That is the piecewise function equation for this graph.